Hello and welcome to the official PIxelV Lighting tutorial. Now, I was actually supposed to make this a very long time ago. In fact, I had made two other lighting tutorials, one of which actually went onto YouTube, although it doesn't exist anymore, and the other one was planned to be a year ago, and it just never came out. So here we are with the official public one, which is actually going to be official this time. No BS going on here. Now, my channel has become such a collection of unorganized content that I feel like a lot of people have probably forgotten who I am almost entirely. So, for those of you who do know who I am, I'm going to be doing a little bit of an intro here. So if you don't want to hear that, you can just skip the intro using the little outliner feature. I know YouTube has that little outliner feature now, where if you put timestamps in the description, it separates it into outlines, and I made this first section called intro. So if you want to get to the actual tutorial and skip this stuff, you can just skip the tutorial section, but I mean the info section. But I do think it's very important that I inform my viewers on who I actually am, and I'm a Blender user. I do lighting mostly, although I've also dabbled in animation and texture making, texture stuff like that. And I also make materials, although materials is a big part of lighting. So it's like, if you want to do a lot of lighting, you got to be good at materials as well. And I co-created with a bunch of other people the animation team, the Minecraft animation team that now is called Starspark Studios, which doesn't really have a line of content yet, but we're working on it. That is currently the focus of everything I'm doing right now. And I've gotten pretty good at lighting. I make a lot of renders, and I've been getting a lot of public attention because I've been posting. Whoop, I slapped my mic stand. I've been posting a lot of my renders on Twitter and various other locations, and I've been getting a lot of publicity for it. And I asked people on Twitter if they would want to see a lighting tutorial, even though I had been planning to do one already. And they were like, yes, come on, man. Where is it, man? Where is the tutorial? So here I am to deliver. Now, for those of you who don't know my Twitter post, I said that this is going to be a 6-video series. I lied, it's actually going to be 7. I realized I completely forgot a video when I was doing the outliner for the lighting tutorial, because there's like I have a Google Doc that tells me what I'm going to be doing in each one, and I realized I completely forgot a video, so it's actually going to be 7 videos. I wanted it to be an even number, but 7 works too. So let's actually get into Blender now. So you have yourself Blender here. When you open Blender, you were first shown this render made by Ian Hubert. Actually a pretty decent render, but that doesn't matter. You actually have the cube, the lamp, and the camera. Now, I'm going to delete the default cube only to add it back. So I just deleted the default cube and I added it back. I feel like a lot of people do this. The point lamp I'm actually going to keep deleted. But let's briefly talk about Blender. So, Blender, I'm not actually going to go into too much detail with, what the specifics of what I'm doing, like in the Blender keybind menu is, because my tutorial is strictly to do lighting. So I'm going to keep all keybinds strictly to lighting purposes, which means that all the other keybinds, such as the keybind I used to add the cube, I'm not going to be going over because it has nothing to do with lighting. It's just general Blender stuff. Same with like this or the pie menus. It's stuff that I don't feel like it's necessary to have the time to explain. You can either figure it out by yourself, or you can, learn it from a different video. So first things first, this lighting tutorial is going to be taking place in Cycles. So we're going to switch our render engine over to it. And one of the first things I do when I set the render engine over to Cycles is that you'll notice that by default, it sets it to CPU. But if you have a GPU and you haven't set up the system settings yet, the device GPU, if you have a GPU, shouldn't actually be working. It should be grayed out, meaning it's not actually functioning on Blender. That is because you don't have your system settings set up. So if we go to Blender, under Edit, Preferences, if we go to Blender Preferences, oh, that's not what I wanted to do. I forgot that's a thing. I completely forgot that if you shake the window, it closes everything. All right. So if you have yourself, I almost shaked the window again. Okay. So if we go down to System, you'll see at the top Cycles Render Devices. It is currently set to none. We are going to set that to CUDA. And from here you can enable your GPU or your GPUs if you have multiple. And you can also enable your CPU here. So let's say you don't have a GPU. CPUs as of 2.8 can actually use the CUDA render engine, which I'm not sure how much of a boost that actually gives it. I'm not sure if there really even is a boost at all. But I don't typically use CPU rendering with CUDA. I don't even use CPU rendering to begin with. I use GPU rendering for the majority of everything I do, because if I do that to CUDA, and now check this out. So there's a little number at the very top. It's going to appear right under here. It's going to tell me how many samples are going by in the rendered viewport. On CPU, oh wait, let me turn on open shading language. On CPU, it does it this quickly, which for a CPU, that's actually pretty darn fast, but that's also because the scene is empty. But if we go over to GPU, look at that number now. Oh yeah, it's like 1 billion times faster. That's because CPUs aren't necessarily built for graphics, because the CPU stands for Central Processing Unit, while GPU stands for Graphics Processing Unit. So the GPU is obviously going to be much better at rendering stuff than the CPU will be. If you don't have a CPU, if you don't have a GPU, that's fine. Most potato-like computers or most like budget computers don't actually have GPUs. They have just graphics cards, which you can actually render with CUDA. I did it again. You can actually render with CUDA using your graphics card, although the technical problems with that are numerous, because I'm pretty sure Blender crashes a lot if you actually end up doing that. Because I remember I have a laptop that has a graphics card on it, and I was in Florida for a week, and I tried rendering using the graphics card. It did not end well. I actually had to use the CPU. I was like, ooh, graphics card, let me turn that on, and it was a grave mistake. So I would mainly only use this if you actually have a GPU to use. Otherwise, you can just use CPU. So enough blabbering about, the devices over here. Let's actually start talking about lighting, which is the reason why you're here. So lighting, I like to do lighting in the shading workspace, because the shading workspace has an image editor over here, a file explorer, which I've never actually personally used a file explorer in this workspace. I actually don't really see the functionality of it being here, but it's here. And then we have our 3D viewport, which just a quick tip: if you want to disable the world background, which I know can be really annoying, you can just go right here and turn it off. So we have ourselves a cube, and for the sake of this tutorial, I'm actually going to keep the cube here. In fact, I'm going to create a little setup of multiple cubes and also like a base plane. You can recreate this if you want to. You don't technically have to. Alright, so I just created this little setup with 3 cubes, and they're all sitting on a plane. So let's start talking about lighting. There are 4 ways in which you can render lighting in Blender. One is using lamps, which are these 4 lamps right here. The 2 is the ambient occlusion feature, not to be confused with this ambient occlusion feature, which are 2 very different features. And I'll be explaining how they are different in probably an upcoming video. Third is the emission node, which is a material-based thing. That's not an emission node. That is also not an emission node. There it is. An emission node, which is a material-based thing. And the 4th thing is the world space, which is this thing right here. Now, we're going to be diving into stuff like ambient occlusion, world space, and, the emission nodes in later videos. The one we're going to be focusing on in this video, the first one, are the lamps. The most basic way to do lighting in Blender. So let's talk about the point lamp, the first lamp. the go-to lamp, the one that Blender actually starts off by opening with one next to a cube. Now the point lamp's job is simple. It shines light in all directions. It's just that easy. It just shines light in all 360 direction. No angle-based stuff. Rotation does nothing to it, since it's just 360. And there are a few universal features that all lamps have. One of which is this color dial, which I somehow changed to red in 2 seconds. Okay, that's cool, I guess. One of which is this color dial, which, you know, changes the color. And then we have the power, which changes how bright the lamp is. These two features are features that all lamps have. It's like, that's why it's separated by this and this. Well, these bottom features are a little bit more exclusive. For the point lamp, you have, let's make this like 200 so we can actually get a reference point here. So for the point lamp, we have a feature called size, which basically determines how big the area in which the light is coming from is. So by default, it's set to 0.25 of a unit, or a meter technically, as the Blender units are called meters, obviously. And you can change this, and essentially by changing the area in which the light is coming from, you're changing how many possible places in which the light can hit. I.e., you're making the shadows smoother. To put it simply, you're making the shadows smoother. If you put the size down to 0, there are no smooth shadows at all, and the shadows are completely sharp, which can be used stylistically if you so choose. Now, 0.25 actually isn't all that bad for a default setting. The shadows are pretty defined, but also have a bit of a smooth edge to them, which I think is actually a pretty good default value. Although I personally, if I want to make my lighting a little bit more cinematic, especially since we're dealing with cubes here, which have a much more, rough edge, I'm going to put this up to 1, just so the shadows are a little bit more balanced. Now, obviously, when you change how big a lamp is, it changes the area, which means that you're also going to have to compensate by turning the strength up. It's just a factor of changing the size. Since there's more area for that light to go onto, the amount of strength you put onto it is going to be spread out more the bigger you make it, which means you're going to have to compensate by making this number bigger. Just a rule of thumb. That goes for any lamp that has a size function, which is all of them. Max bounces, probably not going to have to worry about this feature. This is basically how many times the light can bounce with this specific light alone. It's set to the maximum by default because normally you're not going to have to deal with this at all because this number doesn't determine light bounces. The light paths menu does, which is a completely different thing, which I'm probably going to end up talking later in this video actually, since light pads are actually kind of important. But yeah, this number you're not really have to worry about. This can just stay at the number that it always is at. You'll see, as you can see here, if you set it to 0, the light just doesn't bounce at all. Now this obviously gets rid of some of the noise, but then again, there's also no indirect lighting happening, which can cause some problems in specific scenarios. Which cycles, you want indirect lighting because that's kind of the reason you're even using cycles to begin with, is for the indirect lighting. Cast shadow is pretty straightforward. It just tells the lamp whether or not to cast a shadow. I think you would technically turn this off if you wanted to. I can't actually think of a scenario where you would want this to be turned off, but there's probably some scenario where you want that to be off. Multiple importance. Multiple importance, it's a complex feature. It's kind of hard to explain what it does without absolutely wrecking your mind. Point is, just leave it on. It reduces noise overall, and what it actually does is a kind of complicated to explain. So just leave it on. That's just my advice. All right, so now that we have point lamps set up, let's actually go ahead and put point lamps into the setup. So where do I want point lamps? Well, I'm probably going to want point lamps, surrounding the edges of the scenery to create a nice feel around the edges. So I'm going to go ahead and put 2 point lamps on both corners. Which, by the way, if you do Alt-D to duplicate with data, which if you didn't know, that's a thing you can do, the strength data and also all the data of the lamps is copy pasted over just like it would be with an object. Just a cool little tip there. So let's go ahead and make these lamps a lot brighter, preferably like, I don't know, 500. And, you know, let's go ahead and, you know, change their color. Obviously, I'm actually going to have to duplicate this one because I want them to be 2 different colors. So let's go ahead and make this one, I don't know, a green color. And let's make this one a blue color. A little bit of contrast lighting going on here. All right, so let's talk about the next lamp. We're going to skip sun for now. The area lamp. The area lamp is similar to the point lamp in which it instead only faces in 180 degrees. So it will only cast light under this 180 degree threshold, and you can rotate it to direct where that 180 degree threshold is located. Similar to the point lamp, or exactly like the point lamp, it has a power and it has a color. And interestingly enough, it has the size feature, but it's a little bit more complex than it was in the previous lamp. Here we have a size feature, but we also have a shape feature. And if we set it to rectangle, we now have 2 size features, one for the X and one for the Y. You can also size it by hovering over the edges and just dragging. This is actually a new 2.8 feature. This wasn't a thing you can do back in 2.79. There's also the portal feature, which is something we're going to be getting into in the second video when we do scenery-based lighting. The portal lamp is going to come in handy, but for now, we're not going to worry about it. And then the other 2 shapes are disc, which makes it a circle. It's actually a pretty interesting shape for an area lamp to take. Makes it a little bit more smooth around the edges of it. And then an ellipse is essentially the circle, but now you have 2 values. So I'm going to actually set it to the disc, and I'm going to go ahead and place a area lamp kind of rotated like this a little bit right here on this side, kind of pointing directly over there. Make this one like a red color, and we'll make this one a purplish color. And there you go, we have ourselves an area lamp set up. So now we have ourselves a decent amount of light going on here. Probably should make this a little bigger. Alright, so let's talk about the spot lamp. Spot lamp is pretty self-explanatory. It is a spotlight. You can scale it to make the physical appearance of this thing bigger, although scaling it doesn't actually change anything with the light at all. It just scales this invisible cone. So scaling is just a visual aid. If you want to make this bigger, you can just make it bigger. It doesn't actually change the lamp at all. It's like scaling the actual object. So here we have power and color like before. Specifically with the spot lamp, you're gonna have to set the power to a really high number, like extremely high compared to all the other lamps. I don't know why this is the way it is. Like you have to set it to like 500 just to even see it. It's like insane how high these numbers have to be. I don't know why this is this way. It's just kind of the way that the spot lamp works. Alright, so you have size, which adjusts the actual size of the lamp itself. And then we have the specifics with the spot, which is the angle of the cone, and also the blend, which the blend is how much the edges blend with the surrounding disc that it is, you know, encompassing. And the default is 0.15, and that's actually a pretty good default go-to. So let's actually make this, let's actually size this up a bit. And we're just gonna make this shine just straight up on this cube, right in the middle. I'm not gonna change anything. Actually going to make the angle slightly smaller, so it's just on that cube. And now we have ourselves a little cube, just kind of chilling in the spotlight. And last lamp is the sun lamp. The sun lamp is located outside of the world space. So no matter where you put it physically in the map, it will not matter. The only thing that matters with the sun lamp is the rotation. Since the sun rays have to be parallel to everything else in the scene, all shadows created by the sun lamp will be parallel to each other, just like it would be with the actual sun. And these numbers, the exact opposite of the spot numbers, these numbers are actually, they have to be a lot smaller. So a number like 4 or 5 is enough to completely light a scene. Especially when you get to outdoor lighting, which we'll be talking about in video 2. And so for this scene, I'm actually going to put it probably below 1, because I want it to have a very, very tiny effect on the actual scenery here. But just for reference for the other features that you can do with the sun lamp, similar to the other lamps, the angle is, in this case, the size value, which by default, it's actually set to 0.526, which if you Google what is the angular diameter of the sun, it'll actually give you 0.5. So this is actually accurate to what the sun's angular diameter actually is in the sky. Good going there, Blender. You put the default value as the right one. So I normally don't ever change that. The only time I ever have to change that number is when it's a cloudy scene. No, that's it. It's just on a cloudy scene, because I was gonna say if it was nighttime, but then again I realized the moon and the sun have the same angular diameter, so it wouldn't make a difference. So I'm gonna put this at a much lower number. Put this at like 0.2, maybe even 0.3. Just get a little bit more of it, but very, very low number. I don't want it to have a lot of effect on the scene itself, so not gonna be a very big number there. Gonna be a relatively small number. And with that, we have a full 4 light setup, which is pretty nice. So let's go ahead and talk about those light pads I was talking about before. So light paths are essentially the Blender's indirect lighting system. So these basically tell you how many times light will bounce off of a kind of material before stopping completely and not rendering any more indirect lighting bounces. So by default, diffuse is set to 4, glossy is set to 4, transparency is set to 8, transmission is set to 12, and volume is set to 0. These are actually pretty good default numbers, except when you're in outdoor scenes, which I'll get into details with in the next video, you probably want to turn diffuse and glossy down to 1, because unless diffuse and glossy, the difference between 1 and 4 is barely even noticeable unless you have a roof over the scene. So you'll notice that 4 and 1 look almost identical with the light bounces here, and that is because there's no roof or ceiling for the diffuse to even bounce onto. It's just bouncing into oblivion. So because of how outdoor scenes work, the numbers for diffuse and glossy can actually be pretty low. I wouldn't recommend putting it at 0 though, because that means that the light doesn't bounce at all, which actually creates a relatively unrealistic look. So you compare 1 to 0. You would want it to have it. You want it to at least be at 1, because at 0 it just kind of looks unrealistic. It looks really flat, looks non-dynamic. This total number is how many light pads are rendered total, regardless of these numbers. So if you have this number at 1, it will completely ignore these numbers and just make everything 1, which is good if you want everything to have a global setting. But normally I just have this number set to whatever the highest number here is, which is 12. Light caustics. These are important, but for now we're going to turn them off because it speeds up render times. They are important, we're going to need them later, but for now you can just leave them off. Adaptive sampling. Turn it on. It basically takes it basically creates dynamic noise, so it allows you to automatically determine where noise can be in certain scenes, and do yada 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 based off of that. Advanced, nothing in here really matters all that much. We're going to get into technical detail with this one in a later video, probably the last one actually. Last thing I want to talk about over here is the different render methods, because we have path tracing and we also have branched path tracing, which is going to be the render method that we're going to be using for this tutorial. I wasn't using it at first because I didn't introduce it at all yet. So with branched path tracing, there's a subsample count, which essentially takes, let's say I put this at 1, just so it's low samples. So it essentially takes I'm just going to make a material for the sake of showing you this. You don't have to do this. So we have a metallic cube in the middle. So everything else here is diffused besides the middle cube. If I turn the diffuse subsample up to 2, 3, 4, 5, you'll notice that the, let me put this at 2. You'll notice that the diffuse is a lot less noisy, but the glossy relatively stays the same until I turn the glossy subsample up. So this allows you to turn specific things up while keeping other things down, which can save you a lot of time, and it also looks better in the long run, especially if you try to reduce noise. It also uses a different method to render noise in a way that's a lot more organized than regular path tracing. So we're going to be using this for the sake of this tutorial. I'm going to remove this material now. And I didn't actually tell you about sample values, so I was going to say that the sample numbers in this one are a lot different than they are in regular, but since I didn't even go over sample numbers at all, I don't have to tell you that. So usually if you're doing HD, usually the number for this can go from like 4 to maybe 6. 6 is like, oh wait, I'm moving the wrong number. 4 to maybe 6. In this specific scenes, it looks like it's probably going to have to be a little higher than that. But if you're doing 4K, it normally doesn't have to go above 2 because 4K is different in the way it functions. We're going to be talking more about how resolution changes the render and the lighting because it does actually change a lot of stuff. So for this case in point, we're going to try to optimize this scene. So right now, if I put this at 4, 4 looks pretty okay, but I think I'm going to have to set a little higher than that. I think I'm going to have to go up to 6 and maybe 8. But first things first, before I try to set up higher, let's try messing with these subsamples. So this is all diffuse, all of it's diffuse. So let's try setting this to like 3. Okay, it looks a lot better now. But I don't think we're going to be getting a lot of quality out of this 1/6 sample, so we're probably going to have to bump this up to 8. 10. You see, the thing is the lighting here is very, very smooth. So, oh, almost forgot to mention, when you go to branched path tracing, every lamp also has a subsample. So let's actually turn all the lamp subsamples up to 2, which will basically make the lights render better. Now I'd say our render is pretty clean, the way it is. Yeah, I'd say it's pretty clean now. So we have ourselves a relatively not noisy image with the help of samples, and now with light pads going on here, because we're doing this, I'm actually going to set this number down to 1, because there is literally no transparency or transmission even in this scene, so neither of these numbers even matter. So I'm just going to, in order to confiscate, I'm just going to turn the total down to 1, which means it's just going to set all of them down to 1. Actually, better idea, I'm just going to turn all 3 of these down to 0 to make it maximum speed. So let's go ahead and render the frame now. I'm not going to get too technical with rendering yet, since that's going to be saved for the compositing video. But you render an image by pressing F12, or if you don't have the F keys for whatever reason, you can go to render and render image, which says F12 next to it. So I'm going to hit F12, which I realized it renders it in a separate image. I forgot about that. Actually, I forgot to pose the camera. Probably should have done that. Oh, nice shot. If you want to change it so that Blender doesn't make a separate window and you want it to render in the image editor, you can just go to Interface, Temporary Windows, and change this to Image Editor, and it'll render down there for some reason. Don't know why it did that. Should not have done that. Should have rendered up here. Alright, so we have ourselves a little bit of an image here going on. Almost forgot to mention the tile size. I just noticed how small the tile size was because it's set to 64 by default. Let's talk about tile size for a second. So tile size is a very important thing, and if you don't want to get too technical with it, you don't have to. You can just go to add-ons, type auto tile size, turn that bad boy on, and there's an add-on that will automatically determine the tile size that is set for the maximum performance of your current device. If I set this to, you see right here, it's set to these really high numbers. If I set this to CPU, these numbers are going to change to 32. So this thing just automatically determines what's best for your device that you are currently using. For me, it is those really high numbers. So now you see it rendered a lot faster because I set it to a more optimal number. I just realized I didn't set the render samples up. I just set the viewport samples up. All right, there we have our relatively denoised image. Now I like to actually do most of my rendering in the render tab, so I can see it in, you know, a big window. And there you have it. There's basic lighting for you. That's pretty much just going to be the end of this one. I know there's a lot of stuff a lot of technical things that I left out, but a lot of those technical things are going to be saved for, you know, other videos, because this one the main focus of this video was to just do lamps and not get too technical with all the other stuff. So I hope this was a helpful video, and I'll see you in video 2 whenever that is made.